So in step 3, we're going to subset these BGEN files. We're going to take them from these giant files and we're going to just subset them down to the variants that are important for our example, for our score file. And of course, for different score files, we could have different subsets. And this is just my example, my way of going about doing it. You may have your own approach. I know there are experts who've been doing this for years. So please, I would really love to hear any feedback that you have or suggestions for my own work and for my videos to help all of you. But in this next step, step 3, we're going to be subsetting these BGEN files for just the variants of interest so that we can have condensed genotype files going forward. And you may wonder, well, why do we need to do that? Well, some of the files can be quite large over here. You can see that, like for this example here, for chromosome 1, it's like 181 gigabytes, which I know when people talk about terabytes, I mean, this may seem like it's not much, but it is quite a lot. And especially because we want to convert it into like different formats, like a Plink1 format for the PGSC catalog. Calculator, we're going to want to have like a more condensed file, and it'll just be a lot faster for us. So I want to kind of shrink down these files to something more manageable. So that's why I'm going to subset it, because the original files, as you can see, are quite memory intensive. And that's great because that's all data. That's all like really helpful data. But for our score, for this example, we don't care about the other variants. We really just care about our variants, those 21 variants that were determined in that research study on late Alzheimer's disease. So ultimately, our goal is to make those giant files, BGEN files, down into these subset files that will be easier to convert. These BGEN files will be much easier. Like you see here for chromosome 1 now, it's just 15 megabytes. It's going to be so much easier to work with instead of 182 gigabytes. It's so much smaller. It'll be much easier to convert these into the bed files and then, those Plink formats that we can use for the PGS catalog calculator. So that's what we're trying to do. We're trying to shrink down the sizes to make them easier to work with. So yeah, the idea is that, we have for inputs, we have the set of the SNPs for the given chromosome that we want to extract. We have it like as a given text file, like for chromosome 14, we have these 2 SNPs that we want to extract. And then we have this UKB imputation from genotype, the original BGEN files here. This is the original BGEN file. As you see here, it is like pretty much 77 gigabytes. So it's pretty huge, pretty sizable. We have that file here, the BGEN file, and then we have the index file to help us go through this file a lot quicker for chromosome 14 here. So we have the original BGEN file, the indexing file for kind of going through it quickly, and then we have the set of SNPs that we want to extract. So these are like the inputs basically, and then the outputs will be these 3 formats. So the first will be the text file of extracted SNPs here. And it's optional because they're just 2. I wanted to show you that if you want to have a text file, you could have them to see which SNPs you have extracted. And it will tell us that from the BGEN file, this is how it looked. And the BGEN file had these RSIDs, which is what we were indexing. So it did recover these 2 RSIDs here. And this position and all that. So it's saying a BGENX success, total 2 variants, the 2 of 2 were captured, which is great. So that's the text file, the extracted SNPs. And yeah, we subset the BGEN files using BGENX. So if we go to the BGEN documentation here, what you can see here is that it says that BGENX is a tool to create an index of variants in a BGEN file and to use that index for efficient retrieval of data for specific variants or regions. So the command line, or what option and what is here, and then what it does. So we're going to filter our BGEN files based on the reference SNP IDs, these RSIDs. So this INCL RSIDs will say only output variants that have one of the given RSIDs. So we're going to be using this flag over here. That's what we will be doing. And you can see that they have other commands, like if we just want to include range, INCL range is only output variance in one of the given ranges, then we use this command. It says that, oh, I only want variance from this BGEN file, so we use BGENX/G. Then that's what this is saying, BGENX/G, my file.bgen. That's what you need to start off with, this part here. So as you see here, that we do need like this beginning part here, and then that's what we use here, and then we do kind of tag on to it like the other commands that we need. We will tag on to it like these other things here. This list the variance in the index, that's what list is doing. So additional options here. So this one will say, oh, from this BGEN file, only include subset it to only those that are on chromosome 11, between this position and this position, for instance. That's it. But we are going to focus on subsetting it based on those RSIDs, those SNP IDs that we wanted based on our score file. So we're going to adapt this for RSIDs instead. So we have BGENX/G file.bgen include RSIDs, this command here. And then we're going to have a SNP file name.txt, then we're going to have it going to the output here. Because, for instance, if we scroll down on this page, it says that that they have these types of commands here. So, the options above, like INCL RSIDs, so it says that this is what the inclusion criterion on a variant will be output if it satisfies at least one of the inclusion options and does not satisfy any of the exclusion passed in the command if you do the XCL RSID. So we're doing this one here. So it takes either value, so you can say only I want to include this RSID so-and-so, or you can give it a file name. So we, instead of doing the INCL RSIDs and giving a specific RSIDs, we're reading it in from a file name.txt. That's what it's saying, and that's what we're doing. So we're going to be subsetting it, a given BGEN file, given the list of SNPs only in this file name.txt. That's what we're doing for a given BGEN file. So then what you'll see here in the code is that when we run this BGENX/G, this file name INCL RSIDs, this command over here, it's creating the subset BGEN file. So for chromosome 1, it's creating this PGS. This is the score PGS ID here. This is the genome build that I mentioned. This is what it's trying to create here. The chromosome 1.bgen. This is the file it's creating. So this command over here is the one that is creating the subset BGEN file for only the SNPs in the input file. And the command is BGENX/G. This command here, BGEN file name include RSIDs, SNP file name, and it's going to be writing it out to the output BGEN. So for chromosome 1, when CHR equals 1, so I'm showing you what this looks like. Then this BGEN file name is given as this. This is what I've specified here as my BGEN file name. It's this here. That's what this is. So BGEN file name based on chromosome 1, this is C1. It is a UKB22828. This is the field name, C1B0V3.bgen. Then include RSIDs part here. Then for the SNP file name, it comes from this PGS ID. Our PGS ID is this ID here that I've given. And again, you can adjust it based on other things. Like I don't need to have the SNP file name be a certain way, but this is how I named it. So I'm copying my naming conventions, and I'm hard coding, and I'm being dynamic, so I'm not hard coding it, so that you can adjust it if you'd like for your needs. But the SNP file name PGS ID is this in front, and that's what this bracket is doing in Bash. This bracket means that it's a variable name. So you'll see that whenever we have for SNP file name, we'll have this $, then the brackets, the $, then the bracket here. That just tells it that it's a variable to be filled in. So PGS ID, then chromosome 1, then this genome build, So this will be read as PGS, this ID here is PGS ID, then chromosome 1, then the genome build, which I've specified here, is GRCH37. So that will be over here, then rsids.txt. So that's what my SNP file name will be. And for each chromosome, what differs is what this is. This is chromosome 1, so that's why this is 1 here. And then the output BGEN is what I specified over here. So the output BGEN is this part here, where the PGS ID again is this. It's filled in for what this is here. Then the genome build. Then the UKB 228 subset part is all here. Then the chromosome 1 there is there. And then underscore rsids.bgen. So it's basically telling it that from this BGEN file, include the RSIDs that are found in the SNP file name. In this SNP file, include only those. Subset it to only the SNPs found in this text file, and then save the BGEN file as this file name. And this output BGEN, where will it be? It's actually going to be stored in the directory that is mentioned here in the destination part. That's the output folder. When we do like the DX upload parts, we give the destination. That's like telling it where those files will be uploaded to. So here the destination, it's saying that whenever we have writing outputs, please put the outputs, whatever those are, in this location, this output folder. And the output folder here will be Sanya tutorials extracted genotypes BGEN. So it's basically saying that, you know, for this part here, take this, include the RSIDs that are found in this text file, and then store them and output them in this BGEN file. And this BGEN file, this command is saying, will be located in this output folder here. But this is the command for subsetting the BGEN file. So this second line of this command, this BGENX/G output BGEN/index, what it's doing is it's creating the corresponding subset index file, the BGEN.bgi file. And then again, in the BGEN documentation, it says that to use BGENX with your BGEN file, so if you have a myfile.bgen, you use the following process. So BGENX/index/G myfile.bgen creates an index file. The index file will be named myfile.bgen.bgi. So it's the same idea. So we're using BGENX /G, and again, these are flags, so we can shuffle them around as long as we specify them in the commands. So BGENX/G/output BGEN. This is the myfile.bgen. So it was the one that was output here. We want to index this output BGEN file here. We want to index it. So we're going to take it. This is what our myfile BGEN is it's this BGEN file here, and we're going to do -index. So for chromosome 1 CHR1, for instance, because it's looping through the for loop. So when CHR is 1, 2, 3, 4, 5, 6, all the way down to 22. So, when CHR is 1, so for chromosome 1, for instance, the output BGEN is what we were just talking about. It's based on this PGS ID, genome build. This is the name for the output BGEN over here. This is the name here. And so in this command here, it's BGENX/G, this BGEN file that we've created. We're going to be doing the index. So you'll see that this is for chromosome 1, what it's going to be output as. So it'll be the BGEN.bgi. It's going to be an index file that will be output for chromosome 1. And again, it's going to be stored in the output folder here. So it automatically is creating that index file, that BGEN.bgi file. The BGI, the indexing for the BGEN file. That's what it's doing for the file that we've just created. And the semicolon means like there's a set of sequence of commands to run. And the command line, this would be one line, it would execute, then this would execute next, and then this one. So the last line is optional, but and again, it's just because we have a small set of SNPs, so you can do this. You don't need to do this. This is just for like defensive programming and just to see like what SNPs were found. You don't need to use this. It's optional, but it'll give you this text file here. And all I'm doing is bgenx/g output bgen/list, the output found SNPs. So again, the output bgen this is the output bgen was specified in this way here. And then the output found SNPs is given this here, where again the dollar in the brackets, this means that the dollar sign and brackets will be removed, whatever this dollar sign and the bracket sign will be removed and substituted with the name. So this part here will become PGS00053. Then this over here is GRCH37 and so on. This is the BGEN name, then the list. And the output found SNPs, again, this PGS ID is this PGS ID here, genome build, then the rest of it here. And then because CHR is 1, it'll be chr1.txt. So just create a text file of the SNPs that were found in the BGEN file. So just going through the BGEN file that we've created in this set here, it's going through that BGEN file and it's just listing the variants to a text file. And then it's outputting that for our reference. And it's going to be saved again in this extracted genotypes BGEN folder. And so you can do this if the number of SNPs to be extracted is small. It's optional. It's just for you to make sure that it's done. So now we're going to see how we can subset those giant BGEN files using those SNPs that we've specified, and this will be the step 3. So we have those set of BGEN files, those giant files for the UKB imputation from genotype, and again, this can differ based on your needs, but in this example, that's what we're using. So we have the UKB imputation from genotype information. Those BGEN files, BGEN.bgi index files, and the .sample files. We have the information, and we have a list of SNPs that we want to extract from that we've created in those like small little text files for those 10 chromosomes. So we're just going to basically run the code to go through and see if the chromosome is present, like if it's one of those 10 chromosomes, just please select those set of SNPs from that BGEN file and create a mini BGEN file. So what we will be doing is we're going to essentially, go from the UKB imputation from genotype, this raw data we have like the index information, which will help. We have the BGEN files, the original BGEN files. You can see they're quite large, as I was mentioning earlier. We're going to be subsetting these BGEN files using the reference SNP ID information that we have here, like for each of these 10 chromosomes. We're just going to be creating mini files for these tiny variants. And you may just be wondering, well, these are just 21. Is it really worth the hassle? But this is just a toy example. I mean, it's a realistic example for late onset Alzheimer's disease. But in your case, you may have lots more variants or fewer. But this is just an example to show you how you can do that. And you can adjust your pipeline as needed. I'm just showing you what I've done and what works for me right now, knock on wood. But we're going to be essentially going through chromosome 8 and saying, okay, I want to just select both these SNPs here. And then we will be going through the chromosome 8 BGEN file, which is 122 gigabytes, and we're going to be just extracting those 2 SNPs. So to do that, what I'm going to do is I'm going to be running that and monitoring this job. I have the code, as I was mentioning, step 3 subset bgen files.sh, and I'll be running this, which will be going through the UKB imputation from genotype folder that I just showed you. And it's going to be going through the Sanya tutorials PGS SNPs. That's what this folder here is, Sanya tutorial PGS SNPs, in each of the chromosomes here. So it's going to be going through that as well. And the output folder, which does not yet exist, the output folder would be created, and it's going to be called extracted genotypes BGEN. That's what it's going to be called, extracted genotypes BGEN. And that's what we're going to use, essentially. Extracted genotypes BGEN folder is where those extracted files will be output as a new folder. And I'm showing you another way that when we're running this, again, just like when we were running the step 1, how we did the make directory, here we can also make this directory here for this output folder that we've created here. So this is just an additional folder that we needed, and we're going through all the 22 chromosomes. And if that chromosome score file, that SNP file for that chromosome, if it does not exist, we're just going to skip it. But if it does exist, we're going to be subsetting its original BGEN file in this folder. We're going to be subsetting it for those SNPs of interest. That's what we will be doing in that code over here. So we're going to just include those SNPs that are necessary. And if it's not found, we're going to skip it. So how do we run this? So what I'm going to do is I'm just going to, we've uploaded those files. I'm going to do ls, again, just to show you. I'm going to do bash, step 3, subset bgen underscore files.sh. So what you'll see here is it's saying submitting job for chromosome 1, for chromosome 2. See, please note this file is not found for chromosomes 3 or 4. See, those files were missing, right? Those chromosomes were not found in our score file. You know, chromosome 5 is there, chromosome 6, 7, 8, 9, and 10 are missing, so it's skipping those. See, it's skipping those because they don't have any like SNPs in the score file that we're using. 12 and 13 are not found, 15, 16, 17 are not found, and 21 and 22 are not found. So it skipped those. So in the monitor, what we will see here is we just have these jobs here. And these are the chromosomes here. 1, 2, 5, 6, 7, 8, 14, 19, 20. Sorry, I mean for these 11 chromosomes. There are 11 chromosomes, so half of them are found here. For these 11 chromosomes, we're running the file for each of the chromosomes. So yeah, for these 11 chromosomes 1, 2, 5, 6, 7, 8, 11, 14, 18, 19, and 20, it's still running. And you can see that this is what the command looks like here. It's processing chromosome 1. It's using this BGENX command here. It's including the RSIDs. Then it's extracting them into this BGEN. This is the first command, which is just extracting those SNPs that were mentioned. It's in that SNP file. It's extracting them into this tiny BGEN file. And then the next one is it's creating an index file, a bgen.bgi file. And then this one is kind of just listing, it's an optional one, but it's just listing what we found in the bgen files out to this text file. And I'm doing this because we only have 21 variants, so it's just a quick way to check. But when you have a lot of variants, I don't know if I would recommend listing them all out. Like if you've got like millions of variants, it might be a lot, but it's up to you. But you can see that it's running the command here, and it'll take some time to run. That we can monitor them using this command here. So as you see here, what this is showing you is that we're running the job for chromosome 1, and then monitor 11 means that there are 11 jobs that are running, one for each of the 11 chromosomes that we found, because the score file has 11 chromosomes. So it's waiting, and you can see that these are the input files that we're given. We're given it the SNPs that we want to extract based on that score file. We've given it the BGEN file that we want to extract the genotypes from, the original, that UKB imputation from genotype, and we've given it the indexing file for the BGEN. So these are 3 inputs because we've specified that, we've mounted that, we've specified the location of those file paths. So this is what the command is essentially doing. So for chromosome 1, it's running this command line, the CMD. The BGENX/G, this command, this first one is including the, as I was mentioning, just subsetting this BGEN file to only the SNPs found in this SNP-related score file, and then it's saving it as this BGEN. And then this next one is indexing that BGEN file that we had. It's indexing it. And the last command, which is optional, is just trying to list the variants found from the BGEN file into this text file for our reference. It's just telling us what was found. The BGEN file will have the genotype data, the dosages of the individuals, but the text file is just going to tell you like which variants do we have that data for. That's what it's telling you. So yeah, little guy, now we find that there are these 3 outputs. And as I was saying here, that, this output here that is optional, this extracted SNPs, is just going to tell you what were the variants that were found in the BGEN file. The BGEN file has the genotype information, so for the samples, like what are their genotypes? Like, do they have the effect allele and the reference and alternate allele? Like, what is their information? That's what the BGEN files is going to tell you. And the indexing file is going to index this BGEN file. But this text file, which is optional, is just going to tell you in the BGEN file, the genotype data, just what are the variants that we have that information on. That's what this is telling you. What are those variants? The BGEN file will be giving you the genotype, that information for a set of variants, but it's not very easily accessible. So I just want to make sure that we have it for the variant of interest. So we do see that from this BGEN file, it has been subset down to this one variant that we wanted for chromosome 1, because that score file just has that one variant. I know this is very tiny, but yeah, this is just showing you for one variant we have this tiny BGEN file. And in the code, what you'll see over here is this command, and what this is doing is it's seeing that we have the SNP file DX here, and we need to sort of put this here by alerting the cloud platform, the UK Biobank DNAnexus, to check fully if this file exists. So if we have a score file for that given chromosome, so it's going to chromosomes 1 to 22, and essentially it's looking for the SNP file. So in Sanya tutorials, under the PGS SNPs folder, it's looking for the SNP file name, and the SNP file name is given with the PGS ID and the chromosome number and the genome build. So you'll see here it's like PGS ID, CHR8, the genome build GRCH37, RSIDs are TXT. I know I'm a bit involved with the names, but it's just for keeping track of what's going on. So it's searching for that SNP file name here in this location. And again, they all have the same pattern of the ID, PGS ID, CHR number, GRCH37, RSIDs are TXT. So it's just searching to see if that SNP file exists. So it's listing in this and seeing if that file is not found. Then it says, please note that SNP file for chromosome, whatever number that is not found, skipping for RSIDs. And then it's continuing. So in the loop, it's continuing, and it's not going to submit this job because it says that, oh, there's no SNP file, so I don't need to subset the BGEN file. That chromosome did not have any SNPs for that score file, so we don't need to use that chromosome. So there are 11 chromosomes that, as we see here, that had any variance in that score file. So for instance, we will not see it for chromosome like 21 or 22, and it'll skip over those. That's what this is doing. It's defensive programming. So if the score file for the chromosome does not exist in the folder on DNAnexus, we skip this. And again, just to explain that when we're running the CMD, the command, this is using the original file names in the command part. It's using the original file names, BGEN file name, output BGEN. You see that they don't have any like slashes or anything that's telling it which folder it belongs to. When it's reading in BGEN file name, it's this UKBCCHR, like B0v3.bgen. But you may wonder, okay, well, how does it know, right? But the way it knows is when we do the dxrun command, we are specifying the location. So this will upload all of the files using the full file paths that we can reference them. So when we call this BGEN file name, we are telling it here that I want to input the BGEN file name based on this. So I want to go to the input folder, which is bulk imputation UKB imputation from genotype. And that's where the BGEN file name is. And that's the file I want to upload into the workspace. So that's what it's telling you. So when you will see in the command that it has a certain like inputs that it has, this is where it comes from. Mentioning it here. So that's how we can access the BGEN file in this command, because it'll be uploaded based on this part here. We've mentioned the file name, but we've also said where that file name is coming from. And again, the $ and the brackets, they encapsulate the variable name. So that's what we're doing here. And then this destination output folder, which is over here, is just going to be where all like the outputs, this output and the bgen.bgi file output here is, and then this arrow is like output it, like where do you want to put the output? What is the file name? It's saying that I want the output file to be saved in this file name and the output to be saved in this file name. That's what that arrow is saying, like push it there. And the destination is telling you that whatever you're saving and writing out, like where it will be going. And you need to give like the full file paths here when you're using the dxrun part, where these files are located and where. But in this area, you cannot put the full file paths. You have to just, when you for the command, you have to just give the regular names. So you cannot put input folder /bgen file name in this part here. You cannot do that. You can just put bgen file name. It'll get confused otherwise. And but why we do this over here, we're not running any command. We're just sort of seeing why we give the full file paths. We're not running any of the like Swiss Army knife command parts here. We're just seeing if that file exists, which is why we need to have the full file path. So now we can see the progress of these runs for subsetting the BGEN files. So it's taken some time. And time is money on the research analysis platform, so please be mindful. I think when you start off, you have a little gratuity of complimentary small amount that you can use, and that goes really quickly. So what we see here is and this tells you like the cost and all that. So I've finished these processes for all of these 11 chromosomes. So for instance, this is the job that's finished. And the outputs would be this BGEN file, this bgen.bgi file, and this txt file here. Oh. And you can see that this is just one of the SNPs that's been extracted, which is the one that we wanted. And it's extracted it from this, using BGENX. Similarly, we can also see here when we're running through it, just to see what's happening here. It's evaluated, it's processed one variant. And it was successful, and it was uploading these files. So this also shows you that what you have provided when we're uploading the files from the code here, when we've uploaded, using this input folder, the BGEN file name, it uploads, for the given chromosome 1, it uploads it as this BGEN file and then this BGI file. And then it also has uploaded this SNP file here. We have the index file name, which is also corresponding to, BGEN is the BGEN file here. That's what this is here. The index file name is the BGI file. And, for chromosome 1, for instance, and this is the input folder, which is the bulk imputation, UKB imputation from genotype. So we specified this, and this will correspond to this BGEN over here. The second one here will correspond to this BGEN BGI. And the third one, which is the third input here, you see these three inputs, these three here, this corresponds to these three respectively here. And so the third one, which is the SNP file DX, this is Sinai Tutorials PGS SNPs and the SNP file name. And the SNP file name is PGS ID, which is the PGS 00053, then the chromosome, which is chromosome 1, the build, which is the GRCH37, and then the RSID. So I added the name to be a little bit longer just to remind us like what the build is, just for reference. Just for consistency. So it's uploaded this file as well here. So it's uploaded these three files here into the workspace. And then when it's running these commands locally, so these will have to be absolute paths where it needs to know where exactly in the project area are these files, where exactly in this IBD project sign are these files located that you want. Then it's uploading them. And then we're just using the local references. We're using BGEN file name, not with the input folder. We're just using BGEN file name by itself here in the command. We're just using the index file name. No, we don't use it at all here, but it's necessary for the command. And then what we're using is the SNP file name, and the SNP file name was what was part of this SNP file DX here. It was part of that. But here we're just using the local SNP file name. We're just using this over here. We're putting this in the command. So when you see, like what it's doing is it's essentially just looking at the local command. It's just taking this UK, it's taking this here. This one right over here, which corresponds to this file here. It's just taking the local name of it. It's taking the local name of this file here, which corresponds to this once it's been uploaded. And that's because like in this over here, we're just using, once we've uploaded the files, we're just using the local names, SNP file name. We're not using the absolute names. So this is what the command was for chromosome 1. And again, it skips over the chromosomes that were not found. It skips over those. That's what this part here was doing. It's skipping over those. So what we see is this is one example. We can also do this for this other example here, like for chromosome 20, for instance, we can see that this here corresponds to this one being uploaded. This is all for chromosome 20 specific files. This is what the command is run. And these are chromosome 20 specific output files that are given and returned. So similarly, that's what we also will observe for like this chromosome here, chromosome 14. We can also see what extracted SNPs those were here. We got these two SNPs extracted from the BGEN file that we needed. And that's what we were wanting for chromosome 14. We had those two SNPs that we needed. We had those two SNPs. You see for chromosome 14, we had these two SNPs, and those were what was extracted. And this was the command here again, and it's all using local. But to upload it, we needed to give those absolute paths in here so that it knows where those files are located. And then going forward, it's just referencing these local file names. That's what this is showing, local file names for this. And this is what is being output. And I'll show you a couple more examples. This is chromosome 7 specific information, C7, 7, 7, 7, 7, 5. And now what we're going to observe is the following. I mean, if we go here, we now see that there's a new folder. So we've created the new folder, extracted genotypes.bgen. So this new folder is here. And now what we will see in this folder is we will have these, chromosome files, the BGEN, BGI files, and the TXT. So for each of these, we will have for the required, the appropriate chromosomes that were found in the score file. So 3 files for each of the chromosomes. 3 times 11 chromosomes, 33, as expected. So then what we're going to do next is we're going to try to squish and squash and merge these files together into, well, we're going to do that eventually, but what we're going to do next is we're going to convert each of these into the Plink1 binary formats, the BED, BIM, and FAM files, and then we'll squish those into one file across all the chromosomes. So that's what's coming next. So over here, what we will see is that this is the inputs and outputs example for chromosome 1 when we're running it. This is how the command looks. We have these input files again, score files, the BGEN file, BGEN index file, and then these are the output files. This is the BGEN, the output subsetting the BGEN based on the set of SNPs that are in that score file that we need, the BGEN.bgi file for indexing, and then just optional set of extracted chromosome SNPs. And this is what the command looks like for chromosome 1. This is an example for chromosome 20. Just for reference, you can see that this is 20, where every part where the chromosome is mentioned, it's chromosome 20. And the corresponding files for chromosome 20 have been uploaded into that environment. So we can run these commands using these that are required. And even for the BGENX, it may not mention the BGI right away, but internally it does need to have that BGI file. Otherwise it'll complain that, oh, I can't find the indexing file, like where's the indexing file? So it really helps to kind of mention, the indexing file that is there, so that when it's running the command, it'll say, yeah, that's where the indexing file is. When we're going through the BGEN, it's going to want to find its buddy. It's kind of like a cat looking for its owner, its buddy. And this is the outputs for chromosome 20. So we see here that the extracted files will be in the extracted genotypes BGEN subfolder. So we had given the output folder in the code here, assigning tutorials extracted genotypes BGEN. So that's where they will be here, as you can see here, that this is where those files are. And it's specified in the output folder. And that's when we run the dx command and we give it the destination of output folder. That is telling it where the outputs will go.